Okay, a function is a relationship in which each element of the domain is paired with exactly one element of the range. What does this mean? It's like a vending machine, okay? If you hit a button, your choice comes out. If you hit the same button again, that same choice comes out. It's not you hit one button and something else comes out, okay? Each time you hit a button, the same thing will come out. You can't hit the button again and get something different. All right, that is what the concept of a function is. Now, if we look at that in terms of different relations, okay, and different ways to write relations, we've written relations as ordered pairs, as graphs, as mapping, okay? All of those can represent functions as well because a function is a relation. Okay, it is a relation. So example 1, determine whether the relation 6, -3, 4, 1, 7, -2, and -3, 1 is a function. Now, how do we tell that? Well, if you put in an x and you get out a y, you just want to make sure to tell if it's a function, each x that you put in can only have one y that comes out. Just like each button on a Coke machine is going to have one soda that comes out. All right, so here we have an input of 6, an input of 4, an input of 7, an input of -3. Are those all different? Yes. So therefore, is it a function? Yes, it is. Each input has only one output. Now, what would make it not a function? Okay, let me give you an example of that. If you had, say we could start out the same, 6, -3, but then if you had something like 6, 2, and then 4, 1, and 7, -2, okay? Because if you hit 6 and -3 comes out, if you hit 6 again, a 2 comes out, that means that's not a function, okay? So that's an example of something that's not a function. So example 2, determine whether 3x minus y equals 6 is a function. Look at that, that's a straight line. For each x that you put in, only one y comes out. So yes, that is a function, okay? Each x has only one y. Example 3, right here. This is a mapping diagram, okay? -1 goes to 4, -1 goes to 5. What does that tell you? An input of -1 has two different outputs. Therefore, it is not a function. Okay, not a function at all. When you have an input that goes to two different outputs. Now, the vertical line test, that is something dealing with graphs like this. Okay, and what that tells you is if you can draw a vertical line through a graph and it hits the graph more than once, it is not a function. Not a function, okay, if it hits the graph more than once. So this example up here, each graph hits it, or each vertical line hits the graph only once. All right, if you had, say, the graph that looks like this, it's a sideways parabola. If you draw a vertical line right there, boom, hits it twice, this is not a function. Okay, so that's what the vertical line test tells you. So, next, looking at some more examples. Are they functions or not? Well, the inputs, 0, -8, 2, 1. Do any of those repeat? No. So, yes, that is a function. Okay, the next one, 9, -6, 4, 8. We can see 8 goes to two different, 9 goes to two different. So is that a function? No. Okay, no it is not, because 9 goes to two different outputs. So does 8, one of them does. It is not a function. So the next one right here, here's your graph. You have just a bunch of points. Any vertical line go through that twice? No. So yes, it is a function. Okay, by the vertical line test, each vertical line drawn through a point on the graph would only hit that graph once. So yes, it is a function. Okay. Next, we have some U-try problems. Okay, go ahead, pause it, try these. We'll go over the answers tomorrow in class. Next, equations that are functions can be written in a form called function notation. For example, y equals 2x minus 1 can be written as f of x equals 2x minus 1. It is just a change in notation. Okay, it is called function notation, but basically what f of x means is y. So when they're saying if f of x equals 3x minus 4, that's the same thing as saying y equals 3x minus 4. And find each value, well, f of 3 means find y when x equals 3. And we have done plenty of that. Okay, so basically f of 3, all it means is plug 3 in for x, figure out what y equals. Alright, so if you do that, 3 times 3 is 9, minus 4 is 5. So therefore, f of 3 equals 5. F of negative 2, what does that mean? Find y when x equals negative 2. Alright, so 3 times negative 2 is negative 6, minus 4 is negative 10. So f of negative 2 equals negative 10. Alright, so another example, f of x equals 3x plus 2 and g of x equals x squared minus x. Find each value. Well, f of negative 2 just means find y when x equals negative 2 and this equals your y. So we're going to have 3 times negative 2, this goes in for your x. 3 times negative 2 is negative 6, plus 2 is negative 4. Okay, the next one, g of negative 1 plus 4. Well, you need to find this value first. Alright, and that means finding y when x equals negative 1. So here, g of negative 1, that just means y equals negative 1 squared. Sorry, that looks a little confusing there. Let's take one of those out. Let's erase all of it, make it neater. Alright, negative 1 squared minus x. So minus a negative 1. Okay, sometimes you have to put it in twice, and that is fine. So negative 1 squared, negative 1 times negative 1 is 1. And then minus a negative 1, negative 1, negative 1 minus a negative 1 is plus 1. 1 plus 1 is 2. So you have 2 plus 4 equals 6. And that's how you find that. Okay? That one's a little difficult, so let's do one more. Say we have to do g of 2. If you were finding g of 2, that would mean doing 2 squared minus 2. 2 squared, 2 times 2 is 4, minus 2 is 2. And that's it. Okay? That is how you evaluate functions. Simply, the function notation, y just gets replaced with f of x. You can cross out the f of x or g of x and make that y. Okay, if that's easier for you. So all it is a change in notation. It's not anything new. We've been evaluating functions like this. We've been saying if x equals 2, find y. That's all you're doing here. Okay, so the next slide has some you-try problems. Go ahead, pause it, try these, and we will go over them tomorrow. Okay, and that's it for this class. We will pick up topic 7, functions, in the next video, functions part 2.